will demonstrate application 4, inhibitor performance under dynamic conditions. This application will be presented by Meeusen from VUB. Mats, please start your presentation. Floor is yours.
So welcome everyone. I will now present the introduction to App 4. App 4 is developed as an extension of App 3 and it is developed in collaboration with Elsica and the VUB. It is an extension of App 3, meaning that we make the transition from a static water layer to a dynamic water layer, and as such make the first step in order to predict accelerated corrosion tests and how a system behaves under dynamic water conditions. To do so, we have considered 2 VDA tests with a different protocol order for now. And these 2 VDA tests are built in the platform. How did we do that? Starting from their temperature and relative humidity profile and their salt flux concentration description, we have used our developed dynamic electrolyte film corrosion model for a recalculation of these temperature, relative humidity and salt flux into a water layer thickness and a salinity profile in the chamber. This is done using a heat transfer model and taking into account the effect of hygroscopic salts. The second step consists in translation of this salinity profile and the water layer thickness in the accelerated corrosion chamber to flux contributions. And 3 flux contributions are considered. The first flux contribution that is considered is a rain flux, which adds water with a certain salinity, environmental salinity, to the system. The second flux is a condensation evaporation flux, which is a flux of pure water, so water that is purely condensating or evaporating. And the third flux we consider is a runoff flux. So that is water that is actually being removed from the substrate at the bulk concentration, so at the instantaneous concentration at that moment. So that these 3 fluxes are going into the App 4 model, which is the ethic model, together with some extra information, which is the leaching flux. And the leaching flux is coming from App 3. So from App 3, we start from a leaching experiment. That leaching experiment is translated into a memory curve. And a memory curve is simply linking the amount of inhibitor that already has leached to the leaching flux at that moment. So information coming from App 3 and the 3 fluxes that we have been calculated, they are now implemented in the same geometry as before, but now with a dynamic electrolyte, a dynamic water layer on top of the primer and the top coat. So the ethic model, the App 4 model, is the explicit time integration cyclic corrosion model. And it's actually an Euler method. It's a first order numerical procedure in order to calculate under dynamic conditions the pH, the concentration of corrosion products, but also the concentration of leaching species, etc. So there are two different ways of using App 4. Either you can start from App 3, so you use directly the results from App 3 and the leaching curves that comes from App 3, that then is translated in a memory curve as an input for App 4, or you use it standalone, meaning that you use your own leaching curve experimentally, and you don't generate a leaching curve through an App 3 simulation. In order to show you this, I will go now switch to the platform. So this is the landing page of the platform. As you can see, I'm already logged in. So if you go here to App 4 Accelerated Corrosion Tests, you will see a lot of information in the beginning about, as I said in the presentation, which tests are built in. You can read a little bit about the theoretical and scientific background, and some information how to use the 2 apps in its separate ways. So the first option is to use App 3 results, so directly results that are coming from an App 3 static water layer simulation. If you select this, you will see immediately all the different results from UP3 that you already have and that you can use. So I will just select the last one because it's the most up to date. Here you don't have to change anything because at this moment only lithium carbonate is built in. Then you can select which test you want to do, the VDA1 protocol or the VDA2 protocol, and with the information you can see here under which sequence, etc. You can see for each of the tests also what is the temperature and the relative humidity profile, but also the generated film thickness and the molarity of the test conditions as calculated as an input for AP4. So if you want to use, for example, the VDA2, you want to use the same geometry as the AP3, you use the leaching curve from AP3, you select set inputs, okay, and then you run the workflow, and then the simulation is sent for calculation. A second option is that you use, as I said, an experimental leaching curve. So that's AP4 standalone, as we call it. Upon selecting a provide experimental leaching curve, you also have to you also automatically get all the options from the experimental leaching curves that you already have uploaded in your user data catalog. It's a couple of steps to upload your own experimental leaching curve in your user data catalog. And to help you, we have here inserted some instructions, because it's important that you follow these instructions rigorously, because otherwise you won't see here the correct information. You have to give them two experimental settings that you used for your experimental leaching curve. The first one is the primer thickness in the experiment in micrometers, and the second one is the length of the scratch that you have made in the experiment. As such, you define, let's say, the surface through where the inhibitor will be leaching in the defect. Apart from that, you also have to, you don't have to change anything here yet, because we only have lithium carbonate for now. You again select which VDA test, you get some information about the VDA test. Since we are now using AP4 standalone, we cannot use a geometry from AP3 as shown previously, but we have to define our own geometry. You can change the primer thickness, the primer width, the thickness of the top coat, and the defect width. Any change that you will make here will be visible in the image on the right. If you select values that are out of boundary, I think if I select here this, you will see that there becomes a red line around the value showing that this value is not possible. When you're in an acceptable range, you can again press set inputs, and then you can run the workflow sending the simulation for calculation. If you don't want to see the results that you have generated, you go to your user data catalog. So you click on your account, user page, then top right, user data catalog, and then you're in, you see all the results of all the simulations. You can see I started simulation doing some time ago. I will go to the last results, and here you can see I did an AP4 simulation results. So if you click on it, you see this is a standalone AP4 simulation. So what information do you get? You get the experimental leaching curve that you have uploaded. So you can click on it and check, okay, this is the leaching curve I uploaded. You can also see what is the memory curve. So how did that translation of leaching curve go to a memory curve? So that is this information. And then you, of course, can have a look at the results that you generated during your AP4 simulation. So if you press preview table, you get the default plot you get is the pH as a function of time. But you can easily change this to, for example, the water film thickness as a function of time. You see that this is exactly the same as the input, so that means that the model has been running correctly. But you can also get information about all the species that are used in the calculation. So you can see how much lithium that you, in the end, get in your electrolyte, but you can also get the concentration of other species that are taken into account in the simulation. One last feature that is built in is that you can also now see the amount of dissolved sodium, but also the crystallized sodium chloride. So because at some concentrations, the concentration is higher than the solubility limit, so you will have crystallized sodium chloride present. and that you can also visualize. So I think this was a introduction to how to use App4 and how to use App4 in two different cases, coming from an App3 simulation, but also using it standalone as a separate App4 simulation in the platform. The default for App4 is always 1 week for now, but the simulations, typical simulation time is up to 10 minutes for simulating a 168 hours test. Okay, this was it from my side.
Thank you very much, Mats. Small comment, if you start the simulation, please wait a little bit when the result will be provided. And after some time, you will have the simulation results. Sometimes it depends from the complexity of the model and complexity of geometry you will provide here. Thank you very much.